my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So when we talk about thermochemistry, it's really important to consider phase changes. So you might have seen this diagram before in high school, but when you go from a solid to a liquid, it's melting. When you go from liquid to a gas, it's condensation. Gas to solid is deposition. You should know all of these terms. But the new aspect of this is that there's an increase in the enthalpy of the system when you go from a solid to a liquid to a gas. So let me show you some examples of that. So when we look at vaporization, which is when you have a liquid going to a vapor or a gas. So this step right here, this is an endothermic reaction. We talked before about what endothermic meant. It means that the reaction requires heat. If you start out with a cup of water, in order to go from a liquid to a gas, you need to boil it, right? So basically, in order for vaporization to happen, you need to supply heat into the system. And thus, the enthalpy of vaporization, delta H, which is written as VAP, is the enthalpy of the vapor minus the enthalpy of the liquid, which gives a positive value, because remember, positive delta H values are endothermic. Let's do another example, melting. So when you're melting something, this is also called fusion, just another term to remember. This is when you go from a solid to a liquid. So when you have something that's a solid and you want to make it a liquid, what do you have to do? You have to supply heat again, right? So it's the exact same thing. It's endothermic. You need to supply heat for the reaction to occur. So the enthalpy of fusion, which is written like so, is the enthalpy of the liquid minus the enthalpy of the solid, which is, again, positive. Finally, let's look at sublimation, which is going from a solid to a vapor. And you guessed it, when you go from a solid to a gas, it also needs a lot of heat for that to happen, so it's endothermic. And the delta H of sublimation is the H of vapor minus the H of solid, which is positive. So one thing that I wanted to point out here was that we can actually combine these, because remember we talked about how state functions can be additive, right? So the delta H of sublimation is actually the sum of the delta H of fusion and the delta H of vaporization. So now let's look at how that could be. So the delta H of sublimation is right here, right? So to get from a solid to a gas, you can also take two steps. You can do the fusion part to get it to a liquid, and then you can do the vaporization part to get it to a gas. And so this delta H of sublimation can actually be the sum of the delta H of fusion and the delta H of vaporization. This is a very important concept. Because heat is required during melting or boiling, and this is the phase transition, the temperature of the sample remains constant even though heat is being supplied. Okay, so the reason why I mention this now is because now we want to talk about Hess's law. And Hess's law can only work because enthalpy changes are additive. They're state functions and they can be added, like I just showed you right here. So enthalpy change at each step of a multi-step reaction can be added to give the total enthalpy change.